Hello, hello. Today we're going to be talking about solving quadratics, but we're only going to be solving by graphing them and factoring them. Okay, no other way right now. So the first thing we need to do is we need to identify what the solutions of quadratics are. Those are the x values where the graph crosses or touches the x-axis. So in this example, I have a parabola that crosses the x-axis in two places. Those two places then are called the solutions of my quadratic. We also call them roots or zeros. Okay, so they go by a couple different names. So what we're going to do is we're going to write the equation and graph the function and identify the types or how many solutions we're going to have. So the first one is x squared plus 2x plus 3 equals 0. I'm going to go ahead and I'm just going to graph this for you because it's so much easier that way. Maybe. So it's going to look approximately like this. What are the solutions to that parabola? Follow-up question. Did it ever cross my x-axis? So this would have no solutions in the set of real numbers, which we just used the double-walled R to talk about that one, because it did not touch my x-axis. So here's another one. I'm just going to draw an approximate graph. There's a more exact one in my notes. Here's approximately what the parabola looks like for this quadratic. It crosses in two places, so this would have two solutions in the set of real numbers, again using that double-walled R. Those solutions then, we could even go on to identify what they are. They are -2 and +5. The next example we have is -x squared minus 8x minus 16 equals 0. I go ahead and I graph her. And she's going to look something like this. How many times, or did it at all, did my graph cross or touch the x-axis? Well, just one spot, right there at x equals -4. So this has one solution in the set of real numbers, again using that double-walled R. So now we're going to kind of work backwards a little bit just to start building up these equations using the roots that they have. On your homework, there are going to be a couple problems where you actually have to graph this, like doing what we did last lesson, axis of symmetry, vertex, 5 points, all that, and then identify their solutions, okay? So don't do an approximate graph like I did. So we want to write an equation in standard form. Which is y equals ax squared plus bx plus c with the following roots. So on our first one, my roots are 2 and 4. So the way I write these, I write them as x equals 2 and x equals 4. I know eventually I'd like to write them as factors, so I need to subtract the 2 over so it's grouped with my x. I need to subtract the 4 over so it's grouped with my x. Then those expressions are my two factors. Once I have that, I can go ahead and multiply those two factors together with foiling. So multiply my first two terms together, x times x is x squared, x times the -4 is -4x. I get -2x with those, and then a +8, combine like terms, and I get the quadratic that has roots 2 and 4. Let's go ahead and do another one. This time, My roots are going to be -1/3 and 6. So we're going to do the exact same thing that we did before. I have x equals -1/3 and x equals 6. I'm going to go ahead and multiply the 3 over on this one and then add the 1. I'm going to subtract the 6. And then these are my two factors.
Ladies and gentlemen, have a wonderful...
Okay. Bring down my other factor, again written in the parentheses, FOIL it out. I get 3x squared minus 18x plus x minus 6. Combine like terms, 3x squared minus 17x minus 6 equals 0. And that is my quadratic. So there's another example on there I don't think we need to do. If you want to work through it, that is entirely up to you. So now what we're going to do is we're going to work backwards from here. We're going to start with a quadratic and find the roots that created it, or that are the solutions to it. So the quadratic I'm starting with is 35x squared minus 15x. So this is not a quadratic with 3 terms, which means I don't need to do a CB chart anywhere in here. So I'm just going to look at this, and I'm going to ask myself, okay, what can I take out of both of these terms? Well, it's pretty clear to me I can take a 5x out. So when I do, it just goes out front, and I'm left with 7x minus 3. I then take each of these and set them equal to 0. And I solve for x. So divide each side by 5, and I just get x equals 0. On this one, I need to add the 3 over, divide by 7, and those are my two solutions, x equals 0 and x equals 3 over 7. Let's go ahead and do another one. X squared minus 4x minus 21. Again, set it equal to 0. This one does have 3 terms, which means I'm probably going to have to do a CB chart. So when I'm talking about a CB chart, is I look at the last number, that's my C value, my middle number is my B value. So if there's nothing in front of my x squared, I don't have to do any other manipulation. I'm just looking for 2 numbers that multiply together to get a -21 and add together to get a -4. Since this is negative, I know one is going to be positive and one is going to be negative. Since my B term is also negative, I know the bigger number will be negative and the smaller number will be positive. So I'm just looking for 2 numbers. What I come up with are -7 and +3. -7 plus 3 is -4, so that checks out. -7 times 3 is -21. So this factors into x minus 7 and x plus 3. Just like before, I'm going to take both of those terms and set them equal to 0. And I'm going to solve for x. So I get that my two solutions are 7 and -3. Let's go ahead and do another one. This one is x squared minus 36. I don't have anything in common for these 2 terms, so I kind of want to see if I can factor this one using that CB chart. In order to do that, I have to have all 3 terms, so I go ahead and fill in a 0 right here. This means when I do my CB chart, I'm looking for 2 numbers that multiply to a -36 and add to a 0. Well, the only way I can get them to add to a 0 is if they're the same number with the opposite signs, which makes sense because -6 times a +6 equals -36, and -6 plus 6 equals 0. So this factors into x minus 6 and x plus 6. I set each of those equal to 0, and I solve for x. And I get those are my 2 solutions. Let's go ahead and do another one. We actually have 2 examples left, and then we are done. My next example is h of x equals 2x squared plus 7x minus 30. Is there a common factor I can take out of all of my terms? No. Is there a number in front of my x squared? Yes. So I can't do a CB chart just the way it is. That only works if there's no number in front of my x squared. So what I need to do is I need to make it so there's no number in front of my x squared. This is what we call rainbowing. So I'm going to take the coefficient that's in front of my x squared, and I'm going to multiply it into my third term. So when I do that, I'm left with x squared plus 7x minus 60, because negative 30 times 2 is a negative 60. From here, I'm just going to go ahead and factor it like normal using my CB chart. So I'm looking for two numbers that multiply to a negative 60 and add to a 7. I get 12 and negative 5. So this becomes x plus 12 and x minus 5. But wait, this is where we need to pause. I didn't start with this quadratic. I made it. So what I did here, I have to now undo. So because I multiplied a 2 into the last term to create this quadratic, I need to divide 2 out of the two factors that I found. Okay, 12 divided by 2 comes out nice and pretty at x plus 6. 5 over 2 will not reduce, so I go ahead and I kick the denominator over with the variable in front of it. And from here, I can just FOIL. So when I do that, I get 2x squared minus 5x plus 12x minus 30, excuse me. I don't know why I'm doing that. Just kidding. I'm going to take each of those, and I'm going to set them equal to 0. I was going to FOIL that out. Subtract the 6 over, I get x equals negative 6. Add the 5 and divide by 2, and I get x equals a positive 5 halves. So my two solutions are negative 6 and positive 5 halves. We're going to do one more example, and then you are free to do your homework. It should fit. Okay, so I have z of x equals 12x squared minus 2x minus 2. The first thing I want to check for is a common factor that I can take out of all three terms. Turns out there is. I can take a 2 out of all of those terms. So when I do that, I'm left with 6x squared minus x minus 1. From here, I still have a number in front of my x squared, which means I'm still going to have to rainbow. So I have 0 equals 2 times my new quadratic. I can now CB chart that new quadratic. So multiplies together to get negative 6 and adds to get a negative 1. To me, that's negative 3 and positive 2. So now I have 0 equals 2 times x minus 3, x plus 2, but wait, I rainbowed, so now I have to unrainbow. So I'm going to divide a 6 out of both of these factors that I just got. If it doesn't reduce, I kick the denominator over with my variable. On both of these, it turns out it will not reduce, or it will not go to a whole number. So I reduce the fractions, and I'm still going to kick those denominators over with my variables. And now I just need to find my roots. The cool thing is, this common factor I pulled out means absolutely nothing. Because if one of these goes to 0, 2 times 0 is still just 0. So I'm going to take the two factors I found, set them equal to 0, and solve. On this one, I'm going to add 1 and divide by 2. On this one, I'm going to subtract 1 and divide by 3. And those are my two factors. If you have questions, please let me know.